Now let's look at the slope of two special lines, the horizontal line and the vertical line. Here's an example of a horizontal line, the line y equals 2. Here's 2 points, a point -1, 2, and a point 1, 2. Remember, on a horizontal line, the y coordinate is always the same, 2. Okay, if we take the difference, the y2 minus y1 to find the slope, divide by x2 minus x1, we get 2 minus 2, y2 minus y1, 2 minus 2, divided by 1 minus -1, 1 minus -1, which will give us 0 over 2, which is 0. So the slope of any horizontal line is actually always 0 because the y coordinate is always the same. So horizontal line has a slope of 0. Now let's look at a vertical line. If we look at a vertical line, here's the line x equals 2. And we'll notice here, I took 2 points, 2, 2, and the point 2, -1. And we're taking the difference in y's, y2 minus y1, over x2 minus x1. So -1 minus 2, -1 minus 2, that's -3. And 2 minus 2, x2 minus x1, so that's 2 minus 2 is 0. -3 divided by 0 is undefined. In fact, anything divided by 0 is undefined. So the slope of a vertical line is always going to be undefined because the x values are the same. And so the denominator will always be 0. Parallel and perpendicular lines also have special relationships. If we have two lines that are parallel, like L1 and L2, that means their slope will always be the same. So parallel lines have the same slope. Parallel lines never touch. In other words, the slope of line 1 is going to be the same as the slope of line 2, the same numerical value if they're parallel. On the other hand, if we look at perpendicular lines are at 90 degrees to each other. They run at 90 degrees to each other or right angle to each other. Perpendicular lines have slopes that are the negative reciprocals of each other. What does that mean, negative reciprocal? It means, let's take the slope of line 1 as being m1. That slope will be the negative reciprocal of line 2. In other words, it will be equal to 1 over m2, but the negative of that. Okay, so the slope of line 1 is equal to -1 over the slope of line 2 if these lines are perpendicular. We'll do some applications with perpendicular and parallel lines later.